It was January 17th, 1991. The time was 3 a.m. and the location was Baghdad. Saddam Hussein had the fourth largest army on Earth. He had Soviet radars, French missiles, and underground bunkers, which were hardened against conventional bombs. His air defense commanders were watching their screens, fingers on triggers, ready for the most powerful air force in history to come screaming in. But they never saw a thing. 42 F-117 stealth Nighthawks flew 1,271 combat missions over the most heavily defended airspace on the planet. And not a single one was shot down. These targets would have cost hundreds of American lives to destroy, but they were obliterated in the first hours of the war. The world changed that night. And nobody watched more closely than China. For the next 3 decades, Chinese military engineers didn't just admire American stealth technology. They hunted it. They photographed every scrap of wreckage they could find. They analyzed every maintenance document they could steal or buy. They reverse-engineered the materials. They analyzed past failures with great determination, knowing that success in the next war would depend on understanding what America had done wrong. But what they found wasn't a gap in American firepower. There wasn't a gap in pilot training either. It was something far more surprising. The problem was that America had built the greatest fighter jet in the history of aviation, and it was spending most of its life sitting on the ground. Before we go further, I have a question for you. In a one-on-one battle, do you think America has the edge with China? Comment yes or no. To understand why this matters, we need to look at the F-22 Raptor, the aircraft that was supposed to own the sky for the next 50 years. The most advanced air superiority fighter ever built. It requires 30 hours of maintenance for every single hour it flies. 30. 2. One on its worst days, just the stealth coating. That thin, fragile, chemically layered skin that makes it invisible to radar demands up to 1,000 hours of repair work for every 100 hours in the air. A crack you cannot see with the naked eye, a few microns wide. That crack can multiply the F-22's radar signature by a factor of 10, which is the difference between a ghost on an enemy screen and a target their missile can lock onto and kill. China saw all of it. And in 2017, they flew the J-20 Mighty Dragon, a stealth fighter built from the ground up around America's maintenance failures. Today, China operates over 300 J-20s. By 2030, that number could hit 1,000. The United States has a combat-ready F-22 fleet of roughly 150 aircraft, and on any given day, fewer than 70 are actually available to fly. The question every air power analyst in Washington is losing sleep over isn't whether the F-22 can beat the J-20 in a dogfight. It almost certainly can. One American pilot against one Chinese pilot, we win that fight. The question is, does that still matter when the shooting doesn't stop after one day? Wars are not decided in single engagements. They are decided on day 8. Day 12 or day 20, when the ground crews are exhausted, the parts are running out, and every hour of maintenance the F-22 demands is another hour the J-20 is already airborne and looking for targets. That is what this video is about. Not just 2 aircraft. 2 completely different theories of how air power works and which one holds up when the shooting starts and doesn't stop. How many maintenance hours do you think the world's most advanced fighter needs to stay airborne? Drop your number below. Most people are off by a factor of 10. The F-22 ground crew, the most skilled technicians on Earth. There is a room on every F-22 base that most Americans have never heard of. It has no windows. It smells of chemical solvents so strong that the technicians who work there wear full hazmat suits. And the work they do inside is sanding, layering, weighting and sanding again. It is some of the most technically demanding labor performed by any military on Earth. These are the Low Observable Signatures Coordinators, also known as LO techs. And what they maintain is not paint. It is a weapons system. Staff Sergeant Armando Castellon walked a reporter through the process. First, the entire repair area has to be sealed in protective barriers. The solvents and the fine debris that comes off the stealth surface are hazardous. Then the damaged section is sanded by hand and cleaned. Then comes the primer. Layer 1 is the base seal. It has to be cured within specific temperature and humidity tolerances. If it is too hot, too cold, or too humid, the bond fails and you start over from zero. Then there is the conductive layer. These are silver flakes suspended in polyurethane, engineered to absorb incoming radar waves instead of reflecting them back to the enemy. When this is applied, you have to wait for the cure. Then the metallic top coat is applied, which manages heat to reduce the aircraft's infrared signature. Then you have to wait again. The total adds up to 3 layers. Each one depends on the one beneath it. Each one cures on its own schedule. Sergeant Stovall, another LO technician, described the range like this. Repairs run from major 3-week repairs to what we call spike maintenance, which is just over a weekend. 3 weeks for one repair on one aircraft. That is not the exception. That is the baseline. The numbers are stark. When the F-22 was designed, the Air Force set a target of 12 direct maintenance man-hours per flight hour at operational maturity. 2 decades later, the Raptor sits at 30 maintenance man-hours per flight hour, which is 2.5 times the target after 20 years of trying to close that gap. The stealth coating accounts for roughly 1/3 of all that time. The remaining 2/3 are spread across avionics, propulsion, hydraulics, and environmental systems, each requiring certifications that take years to earn and exist nowhere in the civilian world. There is no airline job, no aerospace contractor role that prepares a man or woman for this work. Every single F-22 LO technician built their skill set from scratch inside the United States Air Force. The operating cost per flight hour was confirmed by the Government Accountability Office at $85,325, which is the highest of any fighter in the American inventory, and nearly 3 times what an F-16 costs per hour. And in fiscal year 2024, the F-22's mission-capable rate dropped to 40%, the lowest in 20 years. Fewer than 4 aircraft in 10 are available to fly on any given day. The issue affected the radar cross-section of the F-22 and reduced the effectiveness of the F-22's low observability, which meant enemy aircraft and radars would have a better chance of identifying the aircraft, said U.S. Air Force, Tyndall Air Force Base Public Affairs. 2016, that 40% mission-capable rate is exactly why the comparison with China is so uncomfortable. Because China didn't just build a stealth fighter. They built one after watching the F-22 struggle for 20 years, and they designed it specifically to avoid everything you just heard. What China built, the silk weaving solution. In 2025, a team of Chinese researchers published findings that stopped defense analysts cold. They had solved part of the F-22's stealth coating problem using a technique that is 3,000 years old. The approach draws from ancient jacquard loom weaving, which is a Chinese silk weaving method from the Han Dynasty that creates complex interlocked structures by threading conductive yarns through a warp knit framework. Applied to radar absorbent material, this creates a coating that is not layered on top of the airframe like paint. It is woven into a structural matrix, fundamentally integrated the way fabric is different from lacquer. The resulting material reportedly withstands 93.5 megapascals of tensile stress. This is dramatically more resilient than traditional layered coatings under the exact conditions that destroy the F-22 surface: heat stress from high-speed flight, sand abrasion, and humidity-driven delamination. This is not a one-time breakthrough. It is part of a pattern that has been consistent since the J-20 entered service. Western analysts have noted since 2017 that the J-20's stealth coating appears to require significantly less maintenance than the F-22's. But calling this learning from American challenges understates what actually happened. China treated the F-22's entire maintenance burden as an engineering specification, meaning a detailed list of problems their aircraft needed to not have. Even the J-20's design choices that look like compromises may be deliberate trade-offs. The canard fins at the front of the aircraft are often cited as a stealth disadvantage compared to the F-22's cleaner configuration, and they do produce a slightly larger radar cross-section. But they also improve maneuverability in ways that reduce demands on the flight control system, which in turn reduces maintenance overhead. A marginally larger radar signature may be an acceptable trade for an aircraft that spends far less time in a repair facility. China doesn't publish maintenance man-hours for the J-20. There are no GAO audits, no congressional hearings where Chinese generals justify sustainment costs under oath. What analysts can observe is this: over 100 J-20s are being produced per year. The aircraft has been deployed to multiple bases, including high-altitude facilities in Tibet. Flying hours have increased steadily since 2020. None of that is consistent with an aircraft spending the majority of its life on the ground. There is one more structural reality that compounds with time. The F-22 is approaching 20 years in service. Maintenance burden on a stealth fighter does not stay constant. It grows as the airframe ages, as the coating degrades cumulatively, as parts become harder to source. The F-22's current 30-to-1 ratio was not what it looked like in 2005. The J-20's ratio, whatever it is today, will look different in 2035. China is on the rising part of that curve. America is near the top of it. This is where the comparison stops being theoretical. In a real Pacific conflict, the question isn't which aircraft wins a single engagement. It's which side can keep more aircraft in the fight across days and weeks of sustained attrition. When you run those numbers, what comes out is something defense planners find genuinely unsettling. The sortie rate war, why turnaround time decides everything. In air power planning, the number that matters most is not radar range, not missile count, and not top speed. It is sortie rate, meaning how many combat missions can an aircraft fly per day. That number is determined by two things: how long each mission takes, and how long the ground crew needs to certify the aircraft for the next one. For the F-22, that second number is the problem. After a mission at high speed, supercruise at Mach 1.8, combat maneuvering that stresses the airframe surface, flight through moisture or sand, the stealth coating requires inspection and potentially repair before the aircraft is cleared for its next mission. Not because of regulations. Because a degraded coating is not a minor problem, it is a mission-critical failure. An F-22 with compromised stealth is not a slightly less capable F-22. It is an F-22 that enemy radar can now find and track. Sending it back into contested airspace in that condition defeats the entire logic of the aircraft's existence. Major repairs take up to 3 weeks. Even spike maintenance, the quick patch, takes the aircraft offline for a full weekend. In a 10-day air war over the Pacific, a Raptor that needs 3 weeks of stealth maintenance after one heavy mission is not flying again for the rest of that conflict. Its contribution ends the moment the coating fails. The J-20's reportedly more durable coating changes this calculation fundamentally. An aircraft that requires less intensive post-mission inspection. That can sustain its stealth performance across more missions before needing significant maintenance generates more sorties per day from the same number of aircraft. And China has significantly more aircraft. In 2024, the People's Liberation Army Air Force operated over 200 J-20s. By 2026, that number had crossed 300, on a trajectory toward 1,000 by 2030, according to RUSI analysis. Against a combat-ready F-22 fleet of roughly 150 aircraft, fewer than 70 are available on any given day at current mission-capable rates. The sortie rate arithmetic shifts in ways that individual aircraft superiority cannot fully offset. This is the turnaround gap. Not the time to refuel and rearm, the time to certify the aircraft as combat effective again. That gap, measured in hours, days, sometimes weeks, determines how many F-22s are actually in the sky at 6 a.m. on day 9 of a Pacific air war. Maintaining these low observable coatings has its own set of challenges: an inexperienced workforce, time-consuming procedures, and demanding maneuvers of a fifth-generation fighter aircraft. said Air Force Institute of Technology. Wright-Patterson Air Force Base in 2011 now here is what most people covering this story miss entirely. America has not been sitting still on this problem. The response to the F-22's maintenance crisis has been one of the largest and least covered defense investments of the past 5 years. America fights back, $11 billion and Raptor 2.0. As we all know, America doesn't accept defeat. Not on the battlefield. And not in the maintenance hangar. In 2026, the United States Air Force announced an $11 billion upgrade program for the F-22 fleet called Raptor 2.0, and one of its largest components speaks directly to everything this video has covered. A $1.3 billion stealth reliability program was aimed specifically at improving the durability of the F-22's low observable materials and reducing the frequency of major repairs. This means new coating formulations, improved application processes, and structural changes to the surface areas most vulnerable to cracking and delamination. The rest of the Raptor 2.0 package addresses the F-22's other critical limitations, which includes stealth-compatible external fuel tanks, the ones that can be carried directly into combat without being jettisoned, adding 850 nautical miles of range. That solves the F-22's biggest strategic liability for Pacific operations, where the distances are vast and every mile of range matters. The upgrade also includes new infrared search and track pods that allow passive target detection without emitting a single radar signal, increasing survivability in environments where using active radar reveals your position. And this is where it gets genuinely exciting. In flight testing, an F-22 pilot has already successfully controlled a General Atomics MQ-20 combat drone from the cockpit, making the Raptor the first crewed fighter to command a collaborative combat aircraft in actual flight. It means one F-22 will be directing multiple armed drones simultaneously. It also means that the effective combat presence of each Raptor will be multiplied without requiring the aircraft itself to fly additional sorties. America invented this technology. American pilots are flying it right now. And no other Air Force on Earth has operational experience with it. Still, none of this erases the maintenance burden the F-22 carries. The aircraft is approaching 20 years in service. The airframes are accumulating hours. The basic physics of a stealth coating that must survive Mach 2 flight in varied atmospheric conditions has not been fully solved by anyone. But the $11 billion signals something critically important. The Air Force has stopped accepting the status quo and started treating the maintenance gap as a strategic problem worth fixing on a war footing. China is not standing still either. Beyond the silk weaving coating research, they are investing heavily in stealth material science. Developing the J-35 carrier-based stealth fighter with lessons from 10 years of J-20 operations, and expanding the network of maintenance facilities and trained technicians that a fleet of hundreds of fifth-generation aircraft requires. The maintenance gap is not a fixed number. It is a competition, fought not in the sky, but in research laboratories, production lines, and training programs that never make the evening news. The bottom line: the F-22 Raptor is still the most capable air superiority fighter in operational service anywhere on Earth. Its ground crews are among the most skilled, most specialized, most dedicated maintenance professionals in any military in human history. What these men and women do every day in rooms with no windows, in hazmat suits, with tolerances measured in microns is technically extraordinary, and it is almost completely invisible to the American public that depends on them. What they are fighting against is not Chinese engineering. It is the accumulated consequence of building an aircraft at the absolute frontier of what was possible in 1990 and operating it for 2 decades in conditions those designers did not fully anticipate. A stealth coating that proved far more fragile in the real world than it appeared in the laboratory. An aircraft that was designed to win every engagement it entered, in a world that turned out to care more about how many engagements you can show up for. China designed the J-20, knowing exactly what the F-22's problem looked like. They had 20 years of American operational data to work from. Whether their solution is as effective as they claim is not fully verifiable, China does not open its maintenance records to outside assessment. What is verifiable is the trajectory. By 2030, China may be operating a J-20 fleet 10 times the size of the combat-ready F-22 fleet, with an aircraft that reportedly costs significantly less to sustain and turns around faster between missions. The turnaround gap that decides wars is not always about what two aircraft can do in a single engagement. It is about which side can keep flying and keep filling the sky when the ground crews are running on 4 hours of sleep and the spare parts are running low. For the F-22, that gap is being addressed. Slowly, expensively, with genuine American investment and genuine American ingenuity. Whether it closes fast enough is the question that the people planning the next Pacific conflict are spending a great deal of money and a great many sleepless nights trying to answer. What gives America the edge still is not just the aircraft. It is the pilots, the training, the decades of real combat experience that no exercises can fully replicate. And now, the technological leap of a crewed fighter commanding a swarm of combat drones that no other military on Earth can match yet. But advantages have to be maintained. They do not maintain themselves. Drop your thoughts in the comments right now. Does the F-22's individual superiority in the air outweigh the J-20's maintenance and production advantages? Or has the turnaround gap already shifted the balance in ways that Raptor 2.0 cannot fully reverse? This is the debate defense planners are having in closed rooms in the Pentagon. Let's have it here.